Lambda expressions are expressions that evaluate two functions. Let's have a demonstration. We already know that I can bind some value to a name, x equals 10. Wouldn't it be nice if somehow I could bind a function to a name using the same syntax, an assignment statement? Now I know I can bind a name to a function by having something that evaluates to a function over here. But what if I want it to be a new function that I've never written down before? How do I do that? Well, one might think that I can just write down what I want the body of that function to be. I want square to be that function that computes x times x. So far I have x bound to 10. And what's square bound to? Well, it's not a function at all. It's just the number 100. And why is that? That's because I evaluated x times x in order to get its value, and that's what I bound to square. Now, what a lambda expression allows you to do is achieve what we wanted in the first place. Bind to the name square using an assignment statement a function that takes in some argument we'll call x and computes x times x as its return value. Now this time, when I look at what square is, I find that it is a function. Excellent. And what does that function do? Well, let's try it out and see. Oh, it squares things. Excellent. So, a lambda expression looks like this. This whole thing is a lambda expression. And it's used to evaluate to functions. I can either take that function and bind a name to it so that I can refer to it later, or I could even apply that function straight away in a call expression where the operator here is a lambda expression, and then I call it on some argument. Let's see what happened right there. I wrote x is 10. I wrote square equals x times x. What happened when I had that assignment statement was that I wrote down an expression that evaluates to a number, and then square was equal to 100. But the second time I tried it, the one that actually worked, I wrote down an expression that evaluates to a function. That lambda keyword introduces a new function in the form of a lambda expression. And the way to read a lambda expression is as a function with formal parameter x that returns the value of x times x. So eventually, people will start to use the word lambda in casual conversation around you. But what they're meaning is an expression that evaluates to a function that can be interpreted in this way. It's important to note that there's no return keyword in a lambda expression. This is a quirk of the expression, that you just write down the return expression directly after the colon without the word return. This limits you to having just a single expression be the body of the lambda function that you create. So lambda expressions create functions, but they always create simple functions that do nothing but evaluate a single expression. Once I've done this, I can square 4 and get 16, and square anything I want. Now, lambda expressions are not particularly common in Python. It's more common to use a def statement. But they are really important in general, and in some programming languages, they're totally fundamental. In other programming languages that didn't have them for a long time, they're starting to appear, because people have realized just how wonderful a lambda expression is. Lambda expressions in Python cannot contain statements, and so they are limited relative to their close cousin, the def statement. So just be aware that if you want to put a while statement inside the body of a function, you can't use lambda. You have to use def. What else is different between a lambda expression versus a def statement? Well, let's figure it out. Face-off time. Over on the left, we've got lambda x is x times x bound to the name square. On the right, we have the def statement version of square. How are these different and how are they the same? Well, it turns out they're almost exactly the same. Both create a function with the same domain, range, and behavior. both functions have as their parent the frame in which they were defined. So the rules for creating functions is exactly the same, whether you use lambda or you use def. Both bind that function to the name square. Well, they do it in very different ways. So this first creates the function with no name at all. And then it's the assignment statement here that binds that function value to the name square. Whereas, in a def statement, both of those things happen automatically. This creates a square function and binds it to the name square, all as a byproduct of executing the def statement. Aha, we found a difference. Only the def statement gives the function an intrinsic name. What's an intrinsic name? Well, it's the name that you see if you actually display what the function is. So if I type in square, it tells me this is a function called, well, lambda. It's not called square, which is different than what I used to get when I type in def square x, return x times x, and then I would look at what square was, and this said function square. So there's this one little place where you'll see a difference, which is what happens when you try to look at the function value and it has a name. That's called the intrinsic name of the function. Now they're both referred to by the name square in the same way. When you put them inside of an expression, all the same rules apply, so they're virtually the same. But this one difference does change a bit how we draw our environment diagrams. So an environment diagram for this example, including the case where I define square equals lambda x, x times x, and then I call square on the number 4, will look like this. We have the name square bound to a function. We introduce a new frame to call that function on 4, and we get a return value of 16. The name square appears in the frame, and these are the names that we actually use in order to evaluate expressions. These are the important ones. In here, we don't write square, but instead write the Greek letter lambda. And that means that when I call this function and I copy all the information over to a frame, well, the name lambda sticks around. But that name isn't really important either. It just helps us keep track of which frame is which. By contrast, when I def square x, return x times x, and then I call square on the number 4, we get this familiar picture where square is bound to a function that's called square intrinsically, and when I call square on some value like 4, then I get a frame that says square in it. Okay, so a tiny difference, really insignificant. But it comes with the fact that this thing had a name when it was created, whereas the lambda didn't have a name until the assignment statement finished giving it one.